All right, let's try a few examples. Notice here that this is an ellipse, the formula of an ellipse, or an equation of an ellipse. You'll notice that these numbers are different. It's equal to 1. If these numbers were the same, then you would go in the same direction, the same distance in both directions, and it would actually be a circle. So the fact that these are different makes it an ellipse. To look for the center, look to see what's added to the x and the y. There's nothing added to x and y, so the center is at 0, 0. If you forget which one is a squared, which one is b squared, it's really not the end of the world, because you're still going to be able to graph this and do all the work. So in this case, a squared is always the bigger one, and then you're going to want to square root that to figure out what the a value is. So the square root of 49 is 7, so a is 7. The square root of 16 is 4, so b is 4. Now here's what I mean about not worrying if it's a or b. The b squared, this number, is under x. Your x-axis goes left and right, so this is going to tell us to go left and right 4 spaces from the center. So you're going to go left 4 spaces, and you're going to go right 4 spaces. The a, the 49, was under the y. Your y-axis goes up and down, so that's going to tell you to go up 7 spaces and to go down 7 spaces from the center. So you can see your ellipses forming here. If you want to go ahead and try to graph that, again, these might not be perfect, just do your best. So you can see that this is tall going up and down, and again, that's because the bigger number was under the y, so that's how we knew that it was going to be a vertical ellipse. The vertices are always the ones that are further away because they're on the major axis, so this is called our major axis. My vertices are at 0, -7, and at 0, 7. So it's these 2 points here. My co-vertices are on the minor axis. They're the ones that aren't as far away from the center, and those are at -4, 0 and at +4, 0. So again, we had this is my major axis, so if I ever ask for it, that's my major axis. And you can actually count how long it is, so that's 14. We will do some word problems that deal with this. The minor axis is the shorter one, so here's the minor axis. And that's 4 plus 4 is 8, so the minor axis is 8 long. Now, we still need to find the foci. The foci are the points that help us actually create this graph. Remember that picture I showed you? Now here it is again if you missed it. It's right there. So these points are the foci, and if you were to like put some string or something and put a pencil, you would actually be able to make an ellipse based off of those foci. All right, back to this. So in order to find where those foci go, we're going to have to do c squared is equal to a squared minus b squared. And again, you'll know right away if you have your a and your b mixed up, if you have a negative value here. You always want to do the bigger number minus the smaller number. So 49 minus 16 is 33. Square root that. It's not going to be pretty. So my c value is radical 33. Now I want to see the foci on here, so you're probably going to want to type that into your calculator, figure out what the square root of 33 is, and it's about 5.7. So again, I want to see those points on, it's always going to be on the major axis. So go up 1, 2, 3, 4, 5, and then just a little bit more. So put those points on there. There's my foci. Let's try another one. All right, so this next one, it's a little bit different looking here. We have nothing added to the x, so my center is going to be at 0, and remember it's the opposite, so 0, 2. So go ahead and plot that point, go over 0, up 2. There's my center. Now, the vertices are the ones that are further away, so those are going to be the bigger number. It's not very nice this time, so this time a squared is 27, a is radical 27, which is 3 radical 3. Again, not super helpful here. So I would change that to a decimal, and that decimal equivalence is about 5.2. And since it's under the x, it means I'm going to go left and right 5.2. So 1, 2, 3, 4, 5, a little bit more. 1, 2, 3, 4, 5, a little bit more. There are my vertices. So let's go ahead and try to write those in. Again, these aren't very nice ordered pairs. So instead of writing negative 5.2, I'm going to do negative 3 radical 3, and then it went up 2. If these get too ugly, usually we're not going to ask you to write the ordered pairs, but this one over here is going to be positive 3 radical 3, and then that's up 2. So there's our vertices. The co-vertices are the ones that are not as far away. So now we're looking at 11. So b squared is 11, is radical 11. Again, not very nice number. Approximate that, it's about 3.3. So I'm going to go up 1, 2, 3 and some, go down 1, 2, 3 and a little bit more. So to write these, if you look, we're really adding to my y value here. So it's still over 0. This point right here, it was at 2, and then I'm going to add radical 11. So it's kind of ugly. It's 2 plus radical 11. See how these can get a little nasty here? My other co-vertice is at 0, and then this went, it was 2, and then I subtracted radical 11 from that. So those are very ugly ordered pairs. C. Again, we're going to find this by doing that c squared equals a squared minus b squared. So a squared was 27, b squared was 11, so 27 minus 11 is 16. We actually get something nice here. So c is 4. Remember, you're always going to travel, your foci are always going to be on the major axis, so that's the one that's the longer one. So it's 1, 2, 3, 4 right there. 1, 2, 3, 4 right there. Plus, if you went up and down 4, you'd actually be outside of that ellipse. I forgot to graph my ellipse. No, there we go, that's not too bad. So there, we've got that graphed. My c value was 4. All right, try another one. If you look at this next one here, you'll notice that it is not equal to 1. In fact, you might glance at it and think that it's a circle just because of how it's written right now. So what we need to do is we need to get it equal to 1. So one way to do that, or the best way to do that, is to go through and divide everything by 100. So that, once we divide everything by 100, let me scooch this up a little bit, we are going to have a formula, an equation that looks like this. So x minus 1, all of it squared, 4 over 100 is 1/25, plus y minus 3 squared, 25 over 100 is 1/4, and equals 1. So now we're in that kind of standard form. So we can look and see that the center is at 1, 3. I wrote that wrong. 1, negative 3. So make sure you copy your equation right. I wrote a plus. So my center is at 1, negative 3. Go over 1, go down 3. There's the center. All right. So if you look, there's a 25 under the x. The bigger number is always a squared. The square root of 25 is 5. X goes left and right. So what you're going to do from here is you're going to go left 5 and you're going to go right 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those are my vertices. So let's go ahead and write those down. Right now, they're pretty easy to look at the graph and determine what they are, but let's do this algebraically. My center was at 1, negative 3. Since this square root of 25 is 5 is under the x, we are going to add and subtract 5 from the x value of the center. So right now I've got 1 minus 5 is going to give me negative 4. The y value stays the same. And I've got a 1 plus 5. So I'm getting the 1 from right here, I'm getting the 5 from right here. 1 plus 5 is 6. Negative 3. I really don't want to write negative 3, do I? So if you double check here, this is at 1, 2, 3, negative 4, negative 3. This is over at 6, negative 3. Let's find our co-vertices. I'll do that with a different color. So the co-vertices are the ones that aren't as far away. So that's going to be my b value. The square root of 4 is 2. So that means I'm going to go up and down 2 spaces from the center. So go up 2, go down 2. Again, you could very easily just look at the graph and determine what those are, but algebraically you're going to add and subtract 2 from your y value. So I had -3, I'm going to subtract 2, so that puts me now at 1, -5, which if you look here, I go over 1, there's -5. I'm also going to use my y value for my center, and I'm going to add 2. So again, -3 came from this, 2 came from this. So -3 plus 2 is -1. Sorry, that's still a +1 there. The x value is 1, and the y value is -1. So there's 1, -1. Or you could just look at the graph. Let me get rid of that. There, I fixed it. It looks a little bit better. All right, so my co-vertices are the ones that aren't as far away. So again, you could do it algebraically by adding and subtracting 2 from the y value for co-vertices. For vertices, you add and subtract 5 from your x value. Or just look at the graph. Then you're going to graph your ellipse, and again, this one is a horizontal ellipse because the bigger number was under the x, and x goes left and right. All right, to find the c value, to find the foci, we're going to do c squared is equal to a squared minus b squared. So that's our 25 and our 4. So 25 minus 4 is 21. To get c by itself, square root it. So my c value is radical 21. Remember, I want to see the points on the graph, so you're going to want to convert that to a decimal so you can count. It's about 4.6. So I'm going to go to the left 4.6 and to the right 4.6. So this time the foci are very close. Sometimes they're not as close to the vertices. All right, a little bit more to go.